There is a new kind of AI out there, and it's doing something we have never seen before. It doesn't just learn language like other models, it organizes language almost exactly like your brain does. Little neighborhoods for verbs, nouns, and meanings, just like what neuroscientists find in real brain scans. And the crazy part? It learned to do this by following just one simple rule. Today, we are diving into what might be one of the most fascinating breakthroughs in brain-inspired AI yet. Let's get into it. This new model is called TopoLM, which stands for Topographic Language Model. It comes from EPFL's NeuroAI lab in Switzerland, a place famous for blending neuroscience and machine learning. Leading the project is Martin Schrimpf, a researcher who has been obsessed with one big question. How close can we get AI models to thinking like actual human brains? And TopoLM was such a big deal, it earned an oral presentation at ICLR 2025, a huge machine learning conference. Only about 2% of papers make it that far. Translation: the AI world thinks this is important. But why? Because for the first time, an AI model isn't just mimicking behavior, it's mimicking brain structure itself. Quick brain science lesson. When you put someone inside an MRI scanner and show them sentences to read, specific parts of their brain light up. One cluster for verbs, actions like run or throw, another cluster for nouns, objects like dog or book, yet another area for syntax, how words fit together into rules. These clusters aren't random, they are organized, almost like neighborhoods in a city. Downtown verbs, suburban nouns, grammar streets, connecting them. This map has been known for a while in vision science. Parts of your brain specialize in faces, colors, and motion. But for language, it has always been harder because language is abstract. There is no clear picture like a cat or a tree, which raised a massive question. Could an AI, trained the right way, spontaneously build these same organized maps for language? The way they did it is almost shockingly simple. They took a smaller version of a transformer AI, about the size of GPT-2 small, and instead of letting its neuron float around randomly in math space, they assigned each neuron a fixed spot on a 2D grid, like streets on a map. Then, they added one simple rule during training. Neurons that are close together should behave similarly. That's it. If two neurons are neighbors, the model gets rewarded when they activate in similar ways. If they are far apart, it doesn't matter. Imagine training a city where cafes all cluster together, school cluster somewhere else, and parks stay grouped. That is basically what the AI is doing, but with meanings instead of buildings. The scientists fed it 10 billion words from educational websites and trained it for nearly a week on 4 monster NVIDIA A100 GPUs. No fancy tricks, no cheating. Just this clean, simple, neighboring units should be similar rule. At the end of the training, they saw something amazing. Verbs organized themselves into a region, nouns into another, grammar structures into yet another. It wasn't random. It looked like a brain map. And when they tested it with real sentences, scrambled sentences, gibberish words, and pure nonsense, TopoLM reacted almost exactly like human brains do. Real sentences lit up strong responses, scrambled or half-nonsense sentences lit up weaker, pure gibberish barely activated anything. Even more impressive, it captured the difference between concrete and abstract words. Just like real brains, TopoLM responded more strongly to words like hammer or kick, things you can imagine touching, than to abstract ideas like freedom or justice. That's something no traditional AI model ever naturally did before. You might ask, does this brain-like mapping hurt performance? Not really. On strict grammar quizzes, TopoLM is about 5% less accurate than a regular model. But on real-world tasks like detecting sentiment, understanding paraphrases, or figuring out entailments, it actually performs slightly better. And when scientists checked how well the AI's activation predicted real human brain signals, TopoLM matched almost perfectly with the best traditional models. In other words, you can get brain-like organization without giving up serious performance. That's huge. Today's AI models, even powerful ones, are mostly black boxes. We know they work, but we don't always know how. TopoLM changes that. You can literally open its brain and point at a blob and say, that's where it processes verbs, that's where it handles nouns. Debugging, way easier. Safety audit, way clearer. Even AI ethics discussions become more grounded when you can actually inspect what the AI is doing internally. And there is a hardware dream too. If we organize AI chips the same way, grouping similar tasks close together, we could build faster, more energy efficient AI systems. Imagine neuromorphic processors that think more like actual brains, saving power and speeding up reasoning. There are also exciting medical possibilities. Imagine using AI brain maps to guide stroke rehabilitation. If a patient loses verb production, doctors could stimulate exactly the cluster TopoLM highlights, or designing brain-machine interfaces that connect to the right language areas automatically. And the team is already partnering with US imaging labs to see if TopoLM can predict language brain areas that scientists haven't even discovered yet. If it does, it could rewrite parts of neuroscience. TopoLM isn't perfect yet. Each layer is the model as its own 2D map, not one continuous sheet like the real brain. It's feed-forward, meaning it processes information in one direction instead of looping signals like brain waves do. Still, as a proof of concept, it's one of the cleanest, strongest pieces of evidence that brains and deep learning might not be so different after all. And maybe, just maybe, the brain strategy for organizing knowledge can be the blueprint for the next generation of AI. TopoLM shows that one simple rule, keep nearby neurons similar, can unlock brain-like intelligence, structure, and understanding, without sacrificing performance, without giving up speed, and without complicated strikes. It's a glimpse of an AI future that's not just powerful, but beautifully organized and maybe even a little more human. Thanks for hanging out for this deep dive into brain-inspired AI. I apologize for the little bugs. If you enjoyed this kind of plain English breakdown, smash that like button, drop your thoughts in the comments, and don't forget to subscribe for more AI discoveries. See you in the